Hello, my name is Taylor Hart, and I will be presenting my research on organic carbon cycling in Santa Clara River particulate matter. I'd like to thank my mentors, Dr. Niels Hodgson, Professor Ellen Druffel, for their help. Some background information on this project. There's been very little previous research on organic carbon cycling in small rivers. The majority has been done on the world's major rivers, such as the Amazon or the Nile, but there's a very big difference between these and the small rivers that we have in California, namely the length, the depth, and the flow rate of the water. This may completely change how the organic carbon is cycled, which is why we need to look at small rivers as well. We'll be looking at the Santa Clara River because it's the largest unaltered river in California. And by the world standard, this is still a small river. Because it's mainly unaltered, we'll get a better insight on natural processes instead of looking at rivers that have been majorly changed by human development. This project also has climate change impacts because understanding carbon in river systems increases understanding of atmospheric carbon sources and sinks. I'll be looking at two things. The first is sources. If the majority of the carbon is very young, it'll have modern sources, such as terrestrial plants or marine plants like algae. But if the majority of carbon is very old, it means that its source is likely from the chemical or physical breakdown of rocks or from petroleum or oil seeps. I'll also be looking at cycling rate. How fast is the organic carbon being cycled? Is it directly being pulled down from the atmosphere by photosynthesis and directly going right back out from respiration? Or is the overall organic carbon being buried over time and being kept for longer? So my research question is, what is the relative age, makeup, and cycling rate of particulate organic carbon, or POC, samples from the Santa Clara River? I've been doing this using carbon isotope ratios and organic compound fractionation. Carbon isotope ratios looks at the ratio of radioactive carbon, or carbon-14, in relation to its more common isotopes, such as carbon-12. More carbon-14 means it has not decayed over time, leading to a modern source, such as terrestrial plants and marine plants. But if there's very little carbon-14 in relation to the other isotopes, it means that it's broken down over time. This means that there is an older source for carbon. The breakdown of rocks, petroleum, oil, it'll basically show the age of the source and how fast it's cycled. But organic compound fractionation looks at the chemical makeup. What is a source? I do this looking at the amount of lipids, the acid-soluble fraction, or amino acids and carbohydrates, and the acid-insoluble fractions. My project includes lab work, working with the Keck Carbon Cycle AMS lab, and data analysis. On the left is the Keck Carbon Cycle AMS lab, and the right is the Druffel lab, where I've been working to prepare these samples and do the compound fractionation. This project will increase our understanding of the role of small rivers in the carbon cycle. Thank you to everyone on my team in the Druffel lab, and of course to Europe for the grant money and for this amazing opportunity. Thank you so much for your consideration.